This is Math 2, 11.2 homework questions. That's Math 2, Unit 11, Lesson 2 homework questions. You should have this worksheet either you printed online, or you wrote the problems down, or you picked a packet up from Clovis West. Okay, so I'm going to do a few of them with you. If you picked up the packet from Clovis West, your worksheet may look a little different. It's similar enough. You can look online and do only the ones that I have on this worksheet, or do all the ones that are on your worksheet. It's up to you. All in all, they are close enough. Okay, I am going to do number 1, and it says solve by completing the square and square rooting. If no real value of x makes the equation true, write none. Okay, so we are solving, and the method we're going to use is complete the square. Now, factoring is a method we've learned, but not everything factors. And so what do we do when not everything factors? We have other methods. One of them is complete the square. This one here does factor, but they want us to complete the square, so that's the method I'm going to use. So the first thing I'm going to do is move that 12 over. And 0 and 12 are like terms. So I'm going to write this as x squared plus 8x plus blank equals 12 plus blank. Okay, so I put the blank in there to complete the squared. 0 plus 12 is 12, and I put blanks on both sides because there is an equation. Cut the 8 in half is 4. 4 squared is 16, and what I add to one side, I must add to the other. I'll repeat that. 8 cut in half is 4, and 4 times 4 is 16. Okay, I'm going to factor this, x and x, and I know they're the same. The neighbor tells me it's plus, and half of, well, what times what is 16? That is exactly the same. That would be 4 and 4. And when you do your inside-outside, you do indeed get the 8x. So I have the quantity of x plus 4 squared equals 20 and 28. And then I'm going to solve. Okay, so I solve by square rooting both sides, and I'm just going to check my work really quick. I square root both sides. And square roots and squares undo each other. Don't forget your plus or minus. X plus 4 equals plus or minus root 28. I'm going to bring my work over here because I'm running out of space. I'm going to subtract the 4. X equals negative 4 plus or minus root 28. Now, 28 is not a perfect squared, and root 28 and negative 4 are not like terms, so I cannot add them together, but I can break the 28 down into pairs. So go ahead and do that now. 2 and 14, 2 and 7. So you have 2, 2, and 7. The 2 is going to come out, so you have negative 4 plus or minus the 2 that comes out and the root 7 that stays in, and that there is your final answer. Okay, because these are not like terms, you cannot add anything together, not even the negative 4 and the 2, because that 2 is attached to the root 7. All right, next one. Number 2, no, I'm going to do number 3 instead. Okay. X squared plus 6x plus 12 equals 0. Okay, so I'm going to subtract the 12. X squared plus 6x plus blank equals 0 minus 12 is negative 12 plus blank. Cut the 6 in half is 3, and 3 times 3 is 9. And what I add to one side, I must add to the other. I factor. It's going to be plus and plus because the neighbor tells me they're positive. 3 and 3, because the numbers have to be the same, equals negative 12 plus 9 is negative 3. x plus 3 quantity squared equals negative 3. We square root both sides. And as of now, we cannot take the square root of a negative without using imaginary numbers. And right here it says we're looking for real values, real solutions, not imaginary solutions, real solutions. We cannot take the square root of a negative, so there's no real solution. It asked us to write none. So none is the answer. None is the answer because you cannot take the square root of a negative number and get a real answer. Okay, so none is the answer for that one. All right, let's see. The next one I do want to do, I'll go ahead and do number 4. Number 4, the 26 has already been added to the other side. You see, like here I had to move the 12, here I had to move the 12, here it's already been moved. So x squared minus 10x plus blank equals 26 plus blank. And then I take the 10, cut it in half, that's negative 5. Negative 5 times negative 5 is positive 25, and what I add to one side I must add to the other. Double bubble. I know the two signs have to be the same. The neighbor tells me they are both negative. And I need two numbers that multiply to 25 that are exactly the same, and that's what I get there. And then 26 plus 25 is 51. I write the quantity of x minus 5 squared equals 51. Square root both sides. Undo, plus or minus, x minus 5 equals plus or minus root 51. I move the 5 over by adding 5 to both sides. X equals positive 5 because I added it over, plus or minus root 51. 51 is not a perfect squared. No pairs come out. These are not like terms. This is as far as I can go. That is my final answer. There are two solutions here, just like there's two solutions up here. We just don't write them separately. You could 5 plus root 51, comma, 5 minus root 51. Negative 4 plus 2 root 7, comma, negative 4 minus 2 root 7. Two separate solutions. This one has none. Okay, lastly I'm going to do number 7. And earlier I said this one factored. It does not. I apologize. I said that, oh, this one factors, but we're not going to factor. This one does not factor. Okay, number 7. Let's see. I do have to move over the 27. And it's not 0 on the other side, so I do have like terms to combine. So that gives me x squared plus 18x plus blank equals negative 32 plus blank. Cut the positive 18 in half, that's 9. 9 times 9 is 81. What I add to one side, I must add to the other. Factor. Negative 32 plus 81 is 49. And x into x, I know the two signs have to be the same. The neighbor tells me they are both positive, and these two numbers are going to be 9 and 9. So x plus 9 quantity squared equals 49. Square root both sides. Undo, plus or minus. X plus 9 equals plus or minus square root of 49, that's a perfect squared, 7. And because, well, I'm going to subtract the 9 first. Negative 9 plus or minus 7. Because these are like terms, I cannot stop here. I stop when they're like this in radicals because they're not like terms, but these two are like terms. I have to add them. Negative 9 plus 7 and negative 9 minus 7. Negative 9 plus 7 and negative 9 minus 7. And negative 9 plus 7 is negative 2, and negative 9 minus 7 is negative 16. That there is your final answer. So two solutions again, two solutions, two solutions, two solutions, no solutions. And that's what this is going to look like on the test. I'm going to move on to the bottom, number 9. And it says, write the following equation in vertex form and find the vertex, the x-intercepts, y-intercepts, and graph for each quadratic function. Okay, write it in vertex form. So let's do that first. It's pretty much what we were doing on our previous worksheet, worksheet 1. It's very similar to what we're doing up here, but up here we were solving. Here we're just rewriting. So we're going to add the 15. That step is still the same. Now what's different is up here in this worksheet they were 0, and we had like 0 plus 15. Here it's not 0, it's y, and y and 15 are not like terms. Y plus 15 equals x squared plus 2x plus blank. Take the middle number, 2, cut in half is 1, 1 times 1 is 1. What I add to one side, I must add to the other. We've done this before. Y plus 16 equals, I know my two signs have to be the same. The neighbor tells me they're both positive. And what times what is 1? That's exactly the same, 1 and 1. So where is this different is right here. Up here on this worksheet, I would have square rooted both sides to solve, but I'm not solving, I'm rewriting. Rewriting means I want to get y equals. So I'm going to subtract 16, which is what we did on worksheet 1. If you go back to your worksheet 1, you'll see them just like this. Y equals the quantity of x plus 1 squared minus 16. There is your vertex form. Y equals the quantity of x plus 1 squared minus 16. Whew. Vertex, opposite of the inside, outside stays the same. So I'm going to put negative 1, comma, negative 16. X-intercepts, y-intercepts. Now I have two forms of this equation. They are both the same equation. This original equation and this one, they're both exactly the same. If I were to plug these two functions into a graphing calculator or into Desmos, they would give me the exact same picture. They just look different. This is standard form. This one down here is vertex form, but they are the same function. So since they're the same function, it doesn't matter which one I use to find my x-intercepts and my y-intercepts. Let's find y-intercepts first. Which one is easier? If you remember from our previous unit, that question was asked, which one's nice to find the y-intercept? That's this one here, because when you find the y-intercept, you make x equal to 0, and that's easy because 0 squared is 0, 2 times 0 is 0, minus 15. 0 plus 0 minus 15 is negative 15. So 0, negative 15. So you just have to kind of know, technically, if you wanted to, you could plug 0 in here. 0 plus 1 is 1, 1 squared is 1, 1 minus 16 is negative 15. You'd get the same answer, it's just this one up here is easier and quicker to get through. Okay, x-intercepts. Which one's easier? It just depends on if it factors or not. Like, it does factor, so you could use this one up here and factor it. I'm going to use this one just to give us the practice, but technically, if you want to try it and see if this one factors and find your x-intercepts. Okay, I'm going to do my x-intercepts in here. Remember x-intercepts, you make y equal to 0. 0 equals x plus 1 squared minus 16. I'm going to add the 16 over. I'm going to square root both sides. Plus or minus. Undo. 16 is a perfect squared, so plus or minus 4 equals x plus 1. Subtract 1 over, so negative 1 plus or minus 4 equals x. So I have negative 1 plus 4 and negative 1 minus 4 for my two x-intercepts. Negative 1 plus 4 is 3, so that's 3, 0. Negative 1 minus 4 is negative 5, so that's negative 5, 0. Now if you factored, you would end up with the same, excuse me, the same x-intercepts. All right, that's all of our information, and we are ready to graph. Now, this is just a generic graph coordinate plane. There are no lines, so you're going to do the best you can. Now, I'm just going to approximate. I'm not going to do all the counting. I'm just going to put negative, let's see, negative 1, negative 16, intercept negative 15. So I'm going to put negative 15 here, which means negative 16 will be there. I'm going to go left 1, down 16. There's my point there. My intercepts, let me draw my axis. My x-intercepts are negative 5 and positive 3. I'm just going to open up. I'm going to fix that. I'm going to fix all of this. Okay, So I'm just going to do this, this, and label. Okay, there's my vertex. My vertex is -1, -16. There's my y-intercept, and my y-intercept is -15. As long as you label everything, there's your two x-intercepts. One was +3, one was -5, so that would be the -5, that would be the +3. And as long as you have everything labeled, you are good. Okay, I do want to talk about one more on the back. And I'm not going to do all of it with you, but I do want to talk about the x-intercepts. Okay, x-intercepts. I said you can find x-intercepts. You know you set the equation equal to 0. And I am going to do that work somewhere else because right in that space is where you would do your work to find your vertex. So I'll do the x-intercepts over here. Okay, you set the equation equal to 0. And you solve. Factor, I would try to factor first. Unfortunately, it does not factor because the two signs have to be the same, and 7 and 1 is not going to give you 6 if the two signs are both positive. So it doesn't factor. So the only other choice we have is to complete the square. Subtract the 7 plus blank on each side. Cut the 6 in half. 6 cut in half is 3. 3 times 3 is 9. What I add to one side, I must add to the other. And that gives me, I want to make sure I'm doing the right one with you guys here. That gives me 7892 equals double bubble. Go ahead and factor that. Plus 3 and 3. And you get x plus 3 quantity squared. Do you see how that works? Okay, so I moved over the 7, -7 plus 9 on each side gave me 2, factored, got that. Square root both sides, plus or minus, square root, undo. I like flipping it over the other way, so I'm going to put my x plus 3 on this side equals plus or minus root 2. Subtract the 3. I'll do that over here. X equals -3 plus or minus root 2. Okay, how did I get that? I subtracted 3 from both sides. -3 plus or minus root 2. Typically, I would stop here and say done. I can't go any further because they're not like terms. But they're asking me to graph this, so I will have to get decimal values. So take out a calculator, take the square root of 2. The square root of 2 is 1.4, rounded to the nearest tenths place, 1.4. And then you do your work. -3 plus 1.4 and -3 minus 1.4. Okay, so let's try that. -3 plus 1.4 gives me -1.6. And then I do it again, but this time they're both -3s, but this time instead of plus 1.4, I'm going to subtract 1.4. So -3 minus 1.4 equals -4.4. All right, so that means your x-intercepts are -1.6, 0 and -4.4, 0. There was one similar to this in notes. Now when you sketch this and you graph it, I didn't find everything else you can find. When you sketch this and graph it, just label your x-intercepts with these two values there. The rest you can do on your own. That is it for these homework questions.